Hello everyone, I'm Niveta K. From the Department of Artificial Intelligence and Data Science in Savita Engineering College. Now I'm going to present my mini project. My mini project is AI-driven Acoustic Surveillance System. I have done this project under the guidance of Dr. Lakshmi C, Department of Scott. So the first and foremost is the agenda, which covers introduction, statement of the problem, purpose of the project, proposed methodology, the results and its implications, literature review, followed by project plan, conclusions, and references. Introduction. Urban safety is a growing concern in modern cities. The traditional surveillance system often fall short in identifying emergency situation promptly. Surveillance system is an innovative solution that leverages advanced audio processing and machine learning to detect distress signals such as themes in real time. Aims to bridge the gap in existing monitoring system by introducing audio-based surveillance for faster emergency response. Moving on to the next thing, that is purpose of the project. The primary objective of this project is to enhance urban safety by incorporating real-time audio surveillance into existing systems. By detecting distress signals promptly, the system aims to reduce emergency response and minimize reliance on manual monitoring to create safer urban environments. It has many beneficial such as enhanced efficiency, real-time alerts and data, cost-effective, scalability, problem detection, improved public safety, reduced response time, non-invasive surveillance, and minimized human error. So we are moving on to the statement of the problem. It mainly focuses on the conventional surveillance system heavily rely on visual data and manual monitoring, which can lead to the delayed responses and inefficiencies in detecting emergencies. Finally, the absence of audio-based monitoring leaves a significant gap in identifying distress situations that may not be visually apparent. The conclusion underscores the need for a robust real-time audio surveillance system. Moving on to the next thing, that is the scope of the project. It uses techniques such as frequency substrate coefficient, short and Fourier transforms, and deep learning models such as CNN, that is conventional neural network, LSTM, that is long short-term memory for accurate classification of sound. It automatically triggers real-time alerts to law enforcement services with relevant metadata with accurate location along with timestamp for immediate response. Here are two kinds of data. One is the process data and system data. Process data will always focuses on the input, that is audio data collections. System data will always focuses on the metadata, which provides accurate location along with timestamp. Statement of the problem. The target audience here are police and emergency teams utilizing real-time alerts for faster intervention. Municipal government that focuses on urban safety. The main goal is to enhance public safety by enabling faster response time from authorities to minimize human error by automating the detection process as well as proactively prevent crimes and improve emergency response in urban environment. Methodology. Here we are classifying the methodology into four kinds. One is the audio data collection and pre-processing, feature extraction, model development and training, followed by real-time detection and alert system. Let's see one by one. Audio feature extraction. It utilizes techniques such as frequency substrate coefficient, spectrogram generation, and short-term Fourier transform to extract relevant audio features. Machine learning models. Conventional neural network support vector machine and long short-term memory networks to classify audio into distress and non-distress categories. Alert system. Generate real-time alert and take the location and timestamp upon detect distress signal and send them to the relevant authorities. Centralized database log all detected events for performance analysis and refinement. Integration ensure compatibility with existing surveillance system and Internet of Things devices for scalable deployment. Result and implications. Result high accuracy in detecting distress signal in real time. Seamless integration with existing urban surveillance system. Reduction emergency response time. Moving on to the next thing, that is architecture diagram. The architecture diagram illustrates the overall structure of the system, showing the flow of data and interactions between components. Components used audio input devices. Microphones capture live audio signals from the environment. Input is sent to the pre-processing unit. Feature extraction module extracts relevant features like MFCC, spectrogram to represent audio signals, converts raw audio into numerical data for pre-processing. Machine learning models (CNN) detect pattern in spectrogram for distress classification. LSTM handles sequential patterns in audio data for accurate prediction. SPM used for multi-classification, generate real-time notification along with location and timestamp, detection and distress signal, sends alerts to authorities via email, messages, or monitoring dashboard. Centralized database stores event logs for performance tracking, future training, and auditing. Integration layer connects the system with existing IoT devices and admin surveillance network. Sequence diagram. This describes the workflow and sequence of operations when detecting a distress signal. Steps: audio capture. Microphones detect ambient sounds. Feature processing. The system extracts relevant features like MFCC. Spectrum from raw audio. Prediction. The process features are passed to the machine learning models. Models classify the signals as distress or non-distress. Alert notification. If distress is detected, the alert system generates a real-time notification. Database logging. The alert, including timestamp and location, is stored in the database. Response. Authorities are notified to take appropriate action. Class diagram. This represents the static structure of the system, showing the relationship and responsibilities of different classes. Use case. This shows how various actors interact with the system and its functionalities. Actors, authorities, raising real-time alerts to respond to distress signals. System admin manages and monitors system performance. IoT devices provides data integration for scalability. Use cases. Capture audio. Microphones record sound from the environment. Process audio. System extracts features and processes audio for classification. Classify signals. Machine models identify distress signals, generate alerts. Notifications are sent to authorities. Log events. Templates database stores logs for analysis. In system. Compatibility with IoT and surveillance networks. Explanation of the components. Audio capture. Capture real-time or sound for analysis. Feature extraction. Converts raw audio to usable data. ML models. Classifies distress signal using AI algorithm. Alert system. Notifies relevant authorities in emergencies. Database. Log events for monitoring, editing, and future improvements. Integration. Extends the system functionality with other devices. Moving on to the next. That is algorithm used. Here we have used three algorithms. The first and foremost is machine learning algorithm. It consists of support vector machine used to classify used for binary classification, random forest used for large and complex dataset, k nearest neighbor. The second one is deep learning algorithm such as conventional neural network, long short-term memory networks. And the third one is feature extraction techniques, includes Mel frequency substrate coefficients and the short-time Fourier transform. Moving on to the hardware selection. Here we are focusing on four major important hardware: microphone, edge computing devices, GPU or CPU, storage devices. Moving on to the next thing, that is software selection. Here the system must install Python to execute our AI-driven acoustic surveillance system. Here, we are considering Tivilo Firebase to store our databases and to push notification to the authorities. The development environment or IDE or code editor includes Google Color, Visual Studio Code for Python development. The for Winston control we are using Git. The next is the implementation. Here, the implementation is classified into six categories. The first one is audio data collection, pre-processing of audio data, feature extraction, model development, real-time detection, and the alert generation. Let's one by one. At first, it requires all the audio data collection, then followed by pre-processing of those data to remove noise, followed by feature extraction. Here we use feature extraction method such as MFCC, spectrogram, and STFT. Followed by we are training model using machine learning as well as deep learning. The machine learning algorithm includes SVM, random forest, and the deep learning models include CNN and LSTM. Then we are focusing on the real-time detection, which captures the audio, processes using feature extraction, and classify using binary classification, and furthermore, the alert generation. It will trigger real-time alert with metadata, which gives accurate location along with timestamp. Moving on to the next thing, important code segment. First, we are importing the libraries. The code imports essential libraries like TensorFlow, LibreSAR for audio pre-processing and Pandas for handling metadata. The metadata file advanced on ak.csv is loaded into a data frame to provide class labels and file path, audio visualization and feature extraction. It loads and visualizes audio files using short-term Fourier transform and MEL spectrogram to analyze characteristic of sounds. A parser function iterates through the dataset to extract MEL spectrogram features for each audio file, convert audio information into meaningful numerical representation. These features are saved into corresponding labels. Model design. A convolutional neural network is defined using Keras. So these are the important code segments. And the last thing is input shape 32, 32, 3 represent resized audio, spectrogram images, layers, two con 2D layers, max pooling for downsampling and dropout to prevent overfitting. The flattened features feed into dense layers with softmax for classification into 10 classes, training and evaluation. The model is trained on the processed data using categorical cross entropy, loss, and add an optimizer for sick epoch. Performance is evaluated on the test set and saved to a CSV. Next, we are moving on to the conclusion. The AI-driven acoustic surveillance system is a transformative approach to urban safety, addressing the limitations of traditional surveillance systems. By incorporating real-time audio monitoring, by leveraging advanced technologies and integrating them into smart city frameworks, the system promises to create safer environments and pave the way for future innovation in public safety. Moving on to the next slide, that is test cases. So here we are considering the criteria of test description, which provides details about the description criteria we have taken and the input, expected output, and actual output we have get, whether the test is pass or fail, and the remarks to improve the system. These are the metrics to evaluate the model that we have created. Our model has an accuracy of 92%. This is the sample output. So these are the future work. The five main future work of our system are enhanced sound classification. So the system to detect additional distress signals such as gunshots, explosions, and emergency alarms. The second thing is multilingual distress detection. It will train models to recognize distress signals in various languages. The third thing is edge computing deployment, so which will implement lightweight models on edge devices like NVIDIA, followed by integration with IoT and smart city infrastructure. This will connect with IoT devices such as CCTV cameras and traffic monitoring system to create a comprehensive surveillance ecosystem. And the last and most important thing is mobile app for real-time alerts. It will develop a user-friendly app to provide security personnel and citizens with real alerts and notification for faster response. Moving on to the next slide, that is references. So these are the related references. So these references